Part 2 of verification of Ohm's law, it is the practical verification of current division rule. So we will perform the part 2 of the experiment by analyzing the schematic diagram given in the experiment. As stated here, we have 3 ammeter then connected to 1 voltmeter or the power supply. So from positive of the power supply, we will connect to the positive of ammeter 1. So here we have the positive polarity. We will connect to positive of our DC ammeter. Ammeter 1, then the negative or the common of ammeter 1 will be connected to the input of R1. So considering that this is our R1, 100 ohms is our R1. The output of R1 will be connected to the ammeter 2. Ammeter 2. So this is our ammeter 2 connected to positive terminal or polarity. Then the negative of the ammeter 2 will be connected together to the negative polarity of ammeter 3. This is the ammeter 3. Then, the positive of ammeter 3 will connect to the positive of the ammeter 3, we will connect to R2. So, this is the R2. Then, the output of the R2 positive will connect to R2. Then the output will be connected together with the negative of ammeter 1. Then the negative of R3, negative polarity of our R3, we will connect directly connected to the negative supply here. So now let us try to check it again. So from positive connected to ammeter 1. So actually the connection is series ammeter. Then from this node connected to R1 and then connected also to R2. And then the output of R2 connected to ammeter 3. The output of R1 will be connected to ammeter 2. And then both common of the ammeter 2 and 3 are connected together up to the negative terminal or polarity of our power supply. Now, let's check, or we will connect first the monitor or digital monitor of our power supply, because the power supply that we are using, it is analog. So take note that the polarity should be from positive to voltage DC. So the range is DC and the negative of the power supply will be connected to common. So let's turn on the power supply. So in part 2 of our experiment, so we will start from input voltage of 10. So we will start the experiment from 10 volts. So our input voltage or given voltage, it is a 10 volts. Okay? Now, let us consider the given resistors. Given resistors R1, we have 100 ohms. R2, we have 330 ohms. So, what is the total current? That is the requirement. But take note that by inspection, you will see immediately if your answer is correct or not by adding the current of ammeter 2 plus the ammeter 3 should be equal to ammeter 1, which is the total current. So you will see immediately by inspection if your connection is correct or not. So we will record now the value of our total current. Total current, we have 13 or 113.2 milliampere. And then the current of I1 or current 2 in ammeter 2, we have 86.8 milliampere. So in our current for the ammeter 3, we have 27 milliampere. Okay. So substituting the value of the resistor 1 and resistor 2 to the given formula. So as you've noticed, the measured value, it is 87.8 or 86.8 milliampere, and the calculated value, it is 86.87 milliampere. So the answer, it is the same. So meaning we can say that the total or the current across R1, it is 87 or 86.87 milliampere. This is our measured value. And then across R2, so substitute again the same. The R1 is 100 ohms and the R2 is 330 ohms. Okay, as you've noticed again, the measured value for our R2 or the ammeter 3, we have 27 milliampere. And then the calculated value, it is 26.32 milliampere. So approximately the same. So we will record now or write now the value of 26.32 milliampere. So what is your remark here? So just compare the equivalent or the reading of the measured value comparing to calculated value. So it means your remark should be, our remark is almost the same. Almost the same, or it means it is, the remark is correct. So let's proceed to 15 volts input of our power supply. So first thing to do, it is to change the R1 equivalent and R2 equivalent. So our resistor value now is 100 ohms and our resistor 2, it is 1000 ohms. 100 ohms and 1000 ohms. And then we will change also the voltage, the input voltage, we will change also. to 15 volts. We will vary to 15 volts DC. Okay, so 15 volts DC. So again, by inspection, we will remove the hold. So by inspection, you will see immediately if your connection is correct or not. 132.2 plus 13, it is equal to 145.8 milliampere. So meaning your answer, your connection is correct. So we will proceed now to the reading. The total current is 100. So R1, we will start from R1. R1 is 100 ohms. And then our R2 is 1000 ohms. And then the total current, it is 146.4. And then the current of our ammeter 2, 132.6. And the current of ammeter 3, it is 13.5. So we will calculate now the value for this, the calculated value as a given resistor. R1 is 100 and R2 is 1000. So based on the calculated value, comparing the value, it is 132.6 as compared to calculated value as 133 milliampere. So it means it's almost the same. So we will record it now, 133 milliampere. So take note that milliampere, for every 1000 ampere, 1 ampere is equivalent to 1000 milliampere. So we are now in the current across or through R2, the calculated value. So the calculated value, it is 13.3 milliampere and the measured value is 13.5 milliampere. So it means it is also almost the same. The answer is almost the same. So it means at 15 volts, having a resistor of 100 and 1000 ohms, we have the same calculated value and measured value. Now we will proceed to the third part, to the 15 or 20 volts input voltage. So we will proceed to 20 volts. So take note that since we have a 20 volts, we are using 20 volts, so it is an ideal also to use a high value of capacitor. So it is advisable to make it the resistor R1 as 330 and then our R2 is 1000. And then we will adjust the power supply to 20 volts. 20 volts. We will adjust power supply to 20 volts. Okay, 20 volts DC. So again, by inspection, you will see immediately if your connection and reading is correct by adding the current of ammeter 2 plus the current of ammeter 3 should be equal to the total current. So we will record now our data. The resistor, it is that we are using 330 ohms and 1000 ohms. The measured value for R2, we have 59.4 milliampere, and then in our wait 59.4 milliampere, and then with the total current we have 78 milliampere. Okay, 78 milliampere, and then the current of ammeter 3, we have a reading of 19.2 milliampere. By calculating the value using the formula, given is 330 ohms and 1000 ohms. 1000 ohms. This is 1000 ohms. So it is stated in the calculated value 58.79, and the measured value it is 59.5. So it is approximately the same. So we will write now the value, the measured value or the calculated value as 58.79 milliampere. Then calculating again the current through R2, okay, so comparing the measured value, our measured current value is 19.2 milliampere, and the calculated current value is 19.4 milliampere. So as a conclusion for this, as the conclusion for the result, you will compare it to the from measured value to calculated value. You can now come up with your remarks. If it is almost the same, as much as possible, not more than two numbers or two digits. Or if it is only a decimal point, it is considered as correct. So again, as a reminder or as take note for this, after the connection, by inspection, you will immediately you will notice immediately if your connection is correct or not by adding the current reading of your ammeter 2 plus the current reading of your ammeter 3. If you will add, the current of the two ammeter should be equal to the total current. So this is now the experiment number 2 or number 1 rather, which is the verification of Ohm's law.